Okay, question 19 next. Let's have a little look at what it says. So, question 19 is find the first three terms. Three terms in ascending powers of x of the binomial expansion. First three terms of x, and we are working on 2 plus px to the power 7, where they're telling us p is a constant. Okay, we then have to do something or another to find out the values of p and q and stuff, but we will work on that in a second. So, the first three terms. So, we are going to be working on 7, 0. There's the first term. We're going to be working on 7, 1. This is your NCR, of course, and your 7, 2. That would give us our first three terms. We are then going to be working on 2 to the power 7, 2 to the power 6, and 2 to the power 5. And that's going to get multiplied by px to the power 0, px to the power 1, and px squared. Okay, so as we put this through, 2 to the power 7 is 128. And of course, 7 to the 0 on the NCR is 1, and anything to the power 0 is 1, so it's just 128. Then we're going to have 7 NCR 1, which gives us 7. So we've got 7 times 2 to the power 6, which is 64. Px, which is 448 px. And then finally, we have 7 NCR2, which gives us 21, times 2 to the power 5, which should be 32, times px, and both of them are squared. 21 times 32, 672, p squared, x squared. Okay, so our first three terms are 128 plus 448 px plus 672 p squared, x squared. Okay, part B. Part B says the first three terms are, it says the first three terms are 128, 2240 x and q x squared, where q is a constant. Find the values of p and q. Well, we can start here by saying, well, those two terms are the same, so we can say 2240 is equal to 448p, so that means p is equal to 2240 divided by 448, 5. Okay, and then we can say up here that the q term would be q is equal to the 672 from up here, p squared. And since p is 5, q is equal to 672 times 25. Okay, so q equals, what's that, 672 times 25, 16800, 16800. There we go, p and q. Question 20 now. Okay, question 20. Question 20. Write down the first three terms in ascending powers of x of the binomial expansion of 1 minus p to the x 12, where p is a non-zero constant. Okay, so watching out for the minus on it. So we are going to have 12, 0. We are going to have 12, 1. And we're going to have 12, 2. And that's going to be 1 to the power of 12, 1 to the power of 11, 1 to the power of 10. Okay, and then we are going to have minus px to the power of 0, minus px to the power of 1, and minus px squared. Okay, so the first lot is equal to 1. The second lot is going to be 12 from the 12 to the 1 for the NCR, this part in the bracket, times 1, so we're going to have minus 12px. This one, the 12 to the 2, 12 NCR 2 is 66, so 66. The minus px squared is going to give us px squared, p squared x squared, of which the minus is changed to a plus. 1 to the power of 10 is 1, so 66 with a positive. Okay, so to write it all out, we are going to have 1 minus 12 px plus 66 p squared x squared. Okay, part A done. Part B. Given that the expression that we just done, the coefficient of x is q and the coefficient of x squared is 6q. Okay, find the values of p and the values of q. So what they're saying is that the coefficient of x, which is minus 12p, is equal to q, and then they are also saying that the coefficient of the x squared, so that's 66p squared, is equal to 6q. Okay, with all that in mind, find p and q, substitute the red one into the green one, so we end up with 66p squared equals 6 times minus 12p. Okay. Right. 12 times 6 is 72, so we end up with 66p squared plus 72p equals 0. Divide through by p, giving us 66, and 72 will divide by 6 as well. So we get 11p plus 12 equals 0, meaning that p is equal to minus 12 divided by 11. Okay, with that in mind, we can substitute it in up here, and we can say minus 12 times minus 12 over 11 equals q. So that's going to be 144 over 11 equals q, which is the final answer. No cancelling. Okay, on with question 21 then, almost at the end of this exercise. Question 21. Find the first three terms, ascending powers, binomial expansion of 2 plus x over 2 to the power 7. Okay, so as always, we're going to have 7, 0, 7, 1, 7, 2 to work them out. Okay, we're going to have 2 to the power 7, 2 to the power 6, 2 to the power 5, and then we're going to have x over 2 to the power 0. We're going to have x to the power 2 over 1, and we're going to have x to the power 2 squared for the first 3 terms. So, okay, so 2 to the power 7 is 128. Okay, 2 to the power 6 is 64, so that's going to be 64. The 7 to the power 1 is going to be 7 times 7, and it's also going to be multiplied by x over 2. So 64 times 7 divided by 2, 224, and then the NCR of 7 NCR2, okay, gives us 21 times 2 to the power 5, which is 32, times x squared over 4, because 2 times 2 is 4. Okay, so 21 times 32, 672 divided by 4 is 168 x squared. This one should be just x. Okay, so we end up with 128 plus 224x plus 168x squared plus. Alright, there's the first 3 terms of that, part A. Part B then. Explain how you would use your expansion to give an estimate for 2.057. So I would look at 2.05 to the power 7, apart from just sticking it straight into a calculator because it's got the ability to do that. But in terms of how you would use your expansion to do that, you would say, obviously, you can take the bracket and say it is equal to 2 plus x over 2 to the power 7, which means you can take your two sides and you can do root 7, giving you 2.05 equals 2 plus x over 2. Take away the 2 on the both sides and you get the 0.05 is equal to x over 2 multiplied by the 2, and we get 0.1 equals x. At this point I can substitute x into the expression, which would be 1.8 plus 224 times 0.1 plus 168 times 0.1 squared plus, and that would then give you your 128 plus your 22.4 plus your what's that going to be, 1.68. Okay, and when you add all of them together, you're going to get 128 plus 22.4 plus 1.68, which gives you a grand total of 152.08, which is a fairly good approximation, considering if you just put into the calculator 2.05 to the power 7, 2.05 to the power 7, okay, you get 152.1517765, which we could also get ourselves if we were to push it out to the nth degree. Okay,